Welcome, my dear students of Class 10 ICSE. Today is question number 24 of the Competency Series, taken from the chapter Work, Energy and Power, the second chapter of physics. It is a very important, a very beautiful competency-based question. We have already done 23 other competency questions in this series, and each and every question that we have done so far is extremely concept oriented and very important. So make sure to watch each and every question of this series. The playlist's link of this competency series is given in the description box of this video. So if you have not watched the previous questions, you can check the link given in the description box of this video so that you can watch all the previous questions. Okay, so let us begin with question 24 now, and let us see what is asked in this question, and let us try to solve this. A body moves along a straight line under the action of a force. Pretty simple to understand the first sentence. There is a body which is moving in a straight line, okay, under the action of some force. The variation of force with displacement is as follows. Now you see how the force varies along with displacement. From x is equal to 0 to x is equal to 4 meters, the force increases uniformly from 0 Newton to 20 Newton. Understand? So displacement is, when the displacement is from 0 meters to 4 meters, the force is not constant. What is written? The force increases uniformly from 0 Newton to 20 Newton. Okay, we will plot this on the graph. Now what about from the next 4, x is equal to 4 to x is equal to 6 meters, the force remains constant. So during this portion from x is equal to 4 meters to x is equal to 6 meters, the force is constant at 20 Newton. And then further from x is equal to 6 meters to x is equal to 10 meters, the force remains constant at minus 10 Newton. Means the direction of force reverses. It remains constant, but the direction of force reverses at minus. What does this minus indicate? It indicates that the direction of force reverses and now it is opposite to the direction of motion. So this minus indicates only that the magnitude of the force is constant at 10 Newton, and minus is indicating that the direction of the force has got reversed. Simple. Now we have to find the total work done by the force. How do we do it? So this is talking about the force and displacement, the variation of the force with displacement. So let us draw the graph showing the variation of the force with displacement. So how do we do it? It's easy. It's very easy. So see, I have already opened up a graph sheet for you, and let us draw this. If you have a graph sheet, better. Otherwise you can draw in your white normal sheet right now, and later on when you have a graph sheet, you do it on that. So you see, it's to be done on the graph. Now here I am plotting this is the x-axis. Now on the x-axis we will show the displacement. So we will plot the points like 0 meters, 1 meter, 2 meter, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So till which we need up to 10 meters. So fine, we have plotted up to 12. That's okay. So we will write, what are we plotting on the x-axis? We are plotting displacement. We are plotting displacement in meters on the x-axis. Okay. Now on the y-axis we are plotting force. This is force versus displacement graph. Now force we need to take like this. We can take 0 Newton here, 5 Newton, 10 Newton, 15 Newton, 20 Newton. Okay, we need up to 20 Newton since this question has a maximum of 20 Newton used. So let us go up to 25 Newton. No worries. Now let us do the same in the negative side. This is minus 5 Newton, minus 10 Newton, minus 15 Newton, minus 20 Newton. Okay, simple. So on the y-axis we are plotting the force in Newton. So I have written force Newton on the y-axis. On the x-axis we are plotting displacement, which is in meters. Easy. Now let us read the question once again. What is being told? From x is equal to 0 to x is equal to 4 meters, the force is increasing from 0 Newton to 20 Newton. So if you see this portion from 0 to 4, these 2 points which I have shown, from 0 meters to 4 meters, how is the force changing? The force is increasing uniformly. The force is increasing uniformly from 0 to 20 Newton. So 0 to, I'm using a straight line from 0 to, you see, 20 Newton, and this change is from 0 to 4 meters. Understand what have I done? You see, the corresponding value over here is 4. The last, where it has reached 20 Newton, where it has reached 20 Newton, that displacement is 4 meters, and by now it has reached this 20 Newton. You can see it has reached 20 Newton, and at what displacement? At 4 meter it has reached 20 Newton, because the question has said that from x is equal to 0 to x is equal to 4, the force will vary from 0 Newton to 20 Newton. So at 20 Newton, when it will achieve 20 Newton, by the when it has completed x is equal to 4 meter, by that time it has reached 20 Newton. Now what about the next portion of the displacement? From x is equal to 0 to x is equal to 6 meter. That means from this 4 to 6, that means this point, it remains constant. It is said in the question the force remains constant at 20 Newton. So let us show it with the red line. You see, I have shown it with the red line. This red line shows what? This red line shows that the force is constant. You can see the constant value is at 20 Newton, during which displacement from x is equal to 4 to x is equal to 6 meters. Now from x is equal to 6 meters to x is equal to 20 meters, not 20, 10 meters, x is equal to 6 to x is equal to 10 meters, the force remains constant once again at minus 10 Newton. So now here is minus 10 Newton, right? Here is minus 10 Newton. So we have to show from 6 to 10, this region, from 6 to 10, you can see the force is at minus 10 Newton. Okay, I hope you are understanding. Simple. Now if I break this graph, I can see the whole thing has 3 shapes. Let me just name them. This is, say, O, this is A, this is B, this is C, this is D, this is E, this is F, this is G. Should I use a darker color? This color is too light to be visible, right? Should I use a darker color? O, A, B, C, D, E, F, G. Okay. I hope things are clear. Let me make it more clean over here. 1 second. Yeah. Yes. Or no more. 1 second. Yes. Now it is better. Okay. Understood? Now you see there are 3 shapes in this graph. There are 3 shapes in this graph. This first triangle is representing what is happening from 0 to 4 meters. Now this rectangle A, B, C, D is representing what is happening in 4 meters to 6 meters, this range, this displacement part. And this rectangle DE, FG is representing what is happening from 6 meters to 10 meters. And the graph has exactly been plotted according to the data given in the question. I hope that is very clear. Now I have to find the total work done by the force. Now, whenever we need to find whenever we need to find work from a force versus displacement graph, we need to find the area under the graph. That's so simple. We need to find the area under the graph. So we will find the area under this triangle. We will find the area under this rectangle, and again area under this rectangle. It's so easy. So let us find the total work done. So I'm doing it here. Total work done is equal to, you see, work done during 0 meter to 4 meter. This part, just for the sake of writing clearly, I'm showing that I am adding 3 separate work done plus work done during which part, 4 meter to 6 meter plus the work done during 6 meter to 10 meter. Okay, now what do? We individually calculate first the work done during 0 meter to 4 meter, which is the triangle. So triangle's area is half into base into height. So if this is the base 0 to 4, the base is 4 and height is, you can see this is the height, which is 20. Clear? So this is the work done during 0 meter to 4 meter plus work done during 4 meter to 6 meter. This rectangle's area. So area of a rectangle is length into breadth. Length, you see, 4 to 6, which is just 2 multiplied with again this, which is 20. So 2 times 20 plus, now you see this part, again a rectangle. So length into breadth. So this is 6 and this is 10. Here is 6, here is 10. That means 10 minus 6 is 4 and the breadth is minus 10 because it's a negative force. Okay, negative force means what? The direction of the force is reversed. Now if you just cancel it, it is 40 plus 40 minus 40. So it gives you 40 joules. So this is the total work done, 40 joules, which is a positive work done over here. So this is the answer to this question. I hope you enjoyed this question. You understood every single part which I explained in this question and you found this important. So make sure to subscribe to the channel if you have not done it yet and also press the bell icon so that you do not miss out any of the competency videos. And again, I must remind you, if you have not checked the previous videos of this series, make sure to do them. The link is given in the description box of this video, so do check the link now. Till then, God bless you, take care and see you in the next video.